Hi, so the topic for today is MinHeap construction code. So basically I will be discussing the coding part or the coding aspect of MinHeap's operations. And what are those operations? There are various 5 or 6 operations like peek, insert, remove, SiftDown, SiftUp and BuildHeap operations. And if you want to know about the in-depth intuition and working of these operations related to MinHeap, then if you haven't already, you should and you must in fact check the previous video. So basically in the previous video I have explained about the working of MinHeap. In the previous video I just explained the working part and not the coding part, but in this video I'm going to be focusing more on the coding part, and I'll maybe go through the one of those operations once again. Okay, so some of the operations which I'm going to cover in the coding part are basically peek, then we can cover insert. We are going to insert a value into the heap. Then I'm going to be covering remove and sift up and then sift down. And I believe so the last one should be build heap, right? The last one should be build heap. So these are basically few of the operations which I'm going to cover in the coding part. And if you have watched the previous video, you already know that insert and remove kind of depends on the sift up and sift down operations. How do they depend? Well, insert actually depends on the sift up operation and remove actually depends on the sift down operation. So when I will be explaining insert and remove, then automatically sift up and sift down will be covered. In fact, build heap is also going to be covering the sift down operation. So indirectly, if I start with insert and remove, then I'm going to be covering the entire part, right? And peek is nothing but getting the topmost element in the root. I mean the topmost element of the heap. And what is the topmost element? What is the property? It's the smallest element among all of the elements present in the heap. And I hope that makes sense. So without further ado, let's get started. Now, I think we should be following a systematic approach. So maybe we will just construct all of these operations here. Let me just have a look. Peek, insert, remove, or I can just look at it one by one. So if name is okay, my bad. So if name is main, and then I'm going to be defining a simple array here, right? An array of numbers. I'm going to try to make it as random as possible, 34, 56, 78, and maybe 3, right? Just trying to make it as random as possible. Now I'll be creating one object, and let's just define it as object underscore 1. This is going to be the object of a particular class. And what will be the class named as? The class will be named as MinHeap, right? As simple as that. So let's just write MinHeap, right? And what will be the default parameter we are going to be passing to the class, right? So it's going to be as simple as array, because the array which I have written here, this array is going to be converted to heap, right? And how do I do that? I firstly create a class called MinHeap and pass this parameter, right? So MinHeap has been created, and then I'll be passing the parameter array. And then at the end, I can just simply print array, right? It's as simple as that. So let's get started with the class part. So I'll just write class MinHeap, right? And then I'm going to be defining the constructor, right? The constructor, and that's really important. So I'll just write define underscore underscore init, and then self comma array, because that's something which I'm passing here, right? That's something which I'm passing here, array. Notice here that I can instead of array maybe write something like arr, right? Or maybe I can just even write heap, and that does not really matters. So even I can just keep it as array, right? After I've defined the constructor, I'll just write self.heap. So self kind of binds it to the class, right? That's what I want it to be. Now self.heap will be basically getting the new heap value after the array has been built up. So what should I do? I'll just write self dot build heap, and within this I'll just pass the parameter as array, right? Because that's this array right here, which is in the constructor, is nothing but this array which I've defined below. Okay, and I hope that makes sense. So right now I can see I'm missing something, right? So self dot build heap. So I'm missing the build heap method in the class. So let's just quickly define that. So I'll just write maybe define the build heap method, right? So I'll just write define build, oh my god, yeah, my bad for the spelling. So it's going to take what? It's going to be taking array as the one input, right? Or as the parameter, or more probably it's, I think it's called argument, right? So this should be array up here. When I'm actually passing, I think I've discussed this earlier as well, when I'm actually passing, actually passing the parameters, when I'm calling it, then I think the parameters, it's called parameters, and when I'm writing it in the function, like right here, then it's called arguments, right? So I am defining the build heap method, right? And I think I'll just leave it for now. I'll just write pass, so it shows me no error right now. I'll complete this. I'll definitely complete this. So complete this. Okay. Now what I'm left with, let's see. We have some operation like peek, right? So let's just define that. So define peek, as simple as that, right? Or define peek, or maybe define, I can write peek the top element, right? Peek the top element or the smallest element. It's the same thing. So what I'm going to do is basically return the topmost element. And how do I do that? I just write return self dot heap of 0, right? Heap of 0 means basically the element at the 0th position, right? It's as simple as that. So I'll just write here define the peek method. This is what I've done here, as simple as that. And then we have insert, right? And before insert, I think I should just write the SiftUp and the SiftDown methods, right? So let's just define that. So define the SiftUp method. So I think I should just go with the SiftUp first. So define SiftUp, right? So I'll just write it in small. It looks good. Now in the SiftUp method, I'm going to be taking basically two parameters. So the first one should be current index. So I'll just write idx and instead of index, right? So idx, I hope that makes sense. And then I'll be having some array or the heap which I'm dealing with. And again, I'll just write pass so as to maybe like complete it later. So complete it, right? So complete this or complete this, I'll just write, okay? So this was the sift up. Then again, I'm just going to be defining sift down here, right? So sift down, and this is going to be taking basically 2 to 3 parameters. Let's see. So sift down self comma, and I believe so we are going to be giving maybe like 3 parameters. So the first one is going to be current index. Again, I'm just writing idx, and I hope that makes sense. And then I'll be writing the end index, right? So what will be the end index? I mean, I can just write end idx just to make sure that we're on the same page. But what will really be the end index? End index will be the last index in the heap, right? Or in the array. It's as simple as that. And then at the end, I'll just pass heap, right? It's as simple as that. And again, I'll just write pass. I'll complete this later. So complete this. Okay. Now, I think we are done with peek, sift up, sift down. I think I have done the build heap as well. Yeah, that's perfect. And I think I'm left with insert and remove. So let's just define that. So define insert method, right? So define, maybe I'll just write simply insert, and then I'll just write self, comma. What will be the parameter or the argument which I'm going to pass to the insert? It's as simple as the value which I will be inserting, right? So value to be inserted, right? You can just simply write value here, right? You can ignore that part, but I'm writing it so that you understand well enough, right? Again, I'll just write pass. So I'll just complete the functions all at once. So complete this, right? And I think we are left with only one functionality. I'll just write here define maybe like a remove, right? Remove method, in which we are simply or essentially removing the topmost or the smallest element out of all the elements. And where is it located? It's located at the top. And if you have watched the previous video, you know for a fact that we kind of swap the topmost and the last element in the heap, and then we proceed, right? So I think there will be no parameters here, right? So there will be no parameters. Why? Because I'm basically removing the topmost element and I don't need anything, right? Just to justify it. So pass and then complete this. And I think we have to start with the complete this thing. And I think I'll just use a helper method, or you can even call it a function, which is swap. And again, if you have watched the last video, you know for a fact that we have done a lot of swap operations, if you kind of recall that, right? So I'll just write swap, right? As simple as that. Swap self. And how do I swap, and what I'm going to swapping, what I'll be swapping. So maybe I can take first index, so first idx, and then maybe I can take second idx, second index, and then I'll just take a heap or an array, whatever you may call it, and then I'll just swap it. So I'll just write heap of first idx. I'm just writing the function up here, and then heap of second idx is as simple as heap of second idx, comma heap of first idx, right? It's as simple as that. Now that we have done the we have written the helper functions here, we'll just proceed with the main part, right? I'll just go up little. Yeah, perfect. So class MinHeap has been created. We'll just recall, we have defined the constructor, we have defined the BuildHeap method, we have defined the peak. I just wrote it peak, the top element, right? And I hope that makes sense. And SiftUp, SiftDown, insert, remove, swap, right? We are good to go. And I think I have only completed 2 operations here, which are peak, right? And the swap completely. I've written it complete. I've written the complete code, right? That's what we are expecting from these methods. Let's just maybe like begin with insert, right? Let's just begin with insert. So what's the parameter saying? Value to be inserted, right? Let's go back to the code part. Let's go. So it's saying insert, right? Maybe let's just take a value like, maybe like take a value like 7, right? Value like 7, or maybe I'll just shorten it a little, maybe like 3. It doesn't matter. So what will be my first approach? What will be my first step? My first step will be to follow the MinHeap's property. What is the MinHeap's property? That it will be a complete binary tree. So basically I will be adding values to the left of the tree, and I'll be adding actually the values as possible to the left of the tree, and then I'll be going to the towards right. So as of now, I can see the leftmost value where I can add is basically a left child of 18, which is value 3. Now that I have added this, I'll just write the code here. So what did I do? I'll just write, I'll remove the past thing, right? So what did I do? I just did this thing, right? So self dot heap dot append, right? So I'm appending the value to the end of the array, right? This is the end part. This is the end part. And that's what I'm doing. I'm appending the value 3 here. So basically append value to be inserted, right? We're done with the first step. It's as simple as that, right? We'll write the code. We'll write the entire code for each and every method just by seeing the diagram here, right? And I hope that will make sense. So let's just get started. So now what I'm going to do here, I'm going to be calling at this point of time the SiftUp method, right? And let's see what the SiftUp method is saying. Let's see. So I'll just write the SiftUp method here. That's not something you have to worry about. So it's saying the current index and heap. It will take the current index and the heap. Not an issue at all, right? So let's just get started. So this will be self dot SiftUp, right? So SiftUp, and what I'm going to be giving. So current index. What will be the current index, right? So my current index will be the index of 3. And where is 3 at? 3 is at the last position of the array or the heap. So this should be self dot, in fact, this should be length of self dot heap minus 1, and this is the last index, right? And then simply I'm going to be passing heap, right? So I'm just going to be passing the heap, right? It's as simple as that. Now that we are done with this part, let's just implement the SiftUp method, right? Because I'm calling the SiftUp here, right? And again, I'm not going to be simply going ahead with the code and just writing the code blindly, right? I'll just explain what I'm doing and then I'll be writing the code. So SiftUp, right? What's SiftUp doing? I know some of you might be aware of this method, but for those who are not, just pay attention. So for the current index, I'll compute the parent index. So parent index is 18 and I'll compare. It's as simple as that. Just pay attention. It's as simple as that if my current index, the element at the current index or the number at current index is smaller than the number at the parent index, I swap, right? I swap. It's as simple as that. So 3 will be swapped with 18, right? 3 comes up here, 18 comes up here. Again, I'll check that is the element at the current index, which is 3, smaller than its parent index. Yes, it is. So I'll just swap. So 12 will come down, right? So 12 will come down and 3 will come up. Sorry for the change of colors, but I hope it's clearer now, right? Again, I'll be comparing my current index or the number at current index, which is 3, and the number at its parent, which is 9. If it's smaller, I swap, right? So I swap here. So I'm going to be getting 3 up here and then 9 up here. And then again, I'm going to be checking that if the number at the current index is smaller than its parent index. But you can kind of see this, right? This is kind of stupid that, well, there is no parent index here, right? This is the end. This is the end. There is no parent index here. So this is the point where we stop, right? It's as simple as that. And now we have the MinHeap tree again, right? Or the properties of MinHeap are satisfying back again. You can check, right? So 3 is smaller than both of its children. 9 is smaller than both of its children. 17 is smaller than both of its children. 12 is smaller than one and only one children, which is 18. 23 is smaller than both of its children. And the whole thing is satisfying the MinHeap properties, right? It's a complete binary tree. It's a binary tree. It's satisfying the property. And at the topmost element, I have 3, which is nothing but the smallest element out of all the elements, right? So what will be the coding part? Let's just get started. So I have a current index, right, which was the current index, which was the 3, which was initially at the last of the array, or the last at the end of the heap. I was not getting the term. So what will I be doing first? Well, firstly, I'll be just calculating the parent index. I could have written index, right, or I can just write IDX. So parent index will be, and again, this is a simple formula which I've discussed in the previous video. So current index minus 1 divided by 2. And again, in Python, if you all don't know, double division is basically integer division or floor division. So basically, in your programming language, you have to be flooring the values, right? And I hope that makes sense. So current index minus 1 divided by 2. It's as simple as that. Now, what will I be doing? Let's see. So I'll be checking that while my current index, right, is actually greater than 0 and the element or the number at the current index, right, the number at the current index is smaller than the number at the parent index. Okay, my bad. So the number at the parent index. And that's what we were doing, right? We were checking that if the number, maybe like we are considering this one, right? If the number at the current index is smaller than the parent index, in this case it's not, but previously it was, right? So if the condition is such, then I'll swap, and this is where my swap functionality will be coming in handy, right? Or coming into action or coming into place. So what I'm going to write here, let's just see. So I'm just going to be writing self.swap. What are the indices I'm going to swap? So the first index I'm going to swap is current index, as simple as that. And I'll be swapping that with the parent index. Well, in which array or heap I will be swapping, right? So the thing which in which I'm going to be swapping, it's going to be heap, right? So again, in the swap operation, the swapping part will take place easily and there will be no problem as such, right? Now that this has been done, what should be my next step? My next step will be to assign the current index with the new value of parent index, right? Or the existing value of parent index. And again, now my parent index value will be computed as current index minus 1, and I'll just use brackets here just to make sense, right? Now that we are done with this, this is the entire part of the SiftUp operations. It's as easy as that. Well, you might be wondering that we have written nothing new, right? Actually, we have written nothing new here, right? Whatever we have discussed here, right? Whatever we have discussed in the implementation part, the swapping part, and when up till when the condition will satisfy, we just use that same logic and wrote the code or the pseudo code here, right? In the SiftUp operation. Now that has been done, this brings me down to the SiftDown operations. But before the SiftDown operations, let's just take a peek at the remove operations. Well, I'll just remove the pass here because we are done with the method. I believe so. Yeah, we are done with the method. Let's just get started with the remove one, right? So for the sake of clear explanation, I'll just kind of try to make the tree again. So I think 9 was there, and then we had maybe like 12, 23, 30, 44. For 12, maybe I can have 17. We can have, let's say 31, right? And then we can have maybe 102 and maybe 32, right? I hope that that's clear, right? The values are not same as of now, but it's following the property here, right? So let's just see, let's just cross check. So 9 is smaller than both of its children, yes. 12 is smaller than both of its children, yes. 23 is smaller than 30 and 44, yes. 17 is smaller than both of its children, yes. 31, 30, 44 are leaf nodes, so I don't need to consider them. As simple as that. So this is my basically MinHeap as of now. Now I'll be explaining MinHeap. Yeah, so I'll be explaining the remove operation. So how do I do that? Now you can clearly see that remove is not taking any arguments, not parameters, but arguments. So this means that I have to basically, even if you do problems later on after getting cleared by the concept, you will be seeing that mostly in MinHeap, the element which we remove is not some random element like 30, 31, or maybe like 32, right? It's basically the topmost or the minimum element among all of the elements, right? Or the topmost root element. So how do I remove that? That's the question here. Let's see. So maybe like imagine after 31 there was one element like maybe 45, right? So that's the left child of 31. What we need to do is basically swap the last most and the first most value, right? So I'm just going to swap 9 and 45, right? I'm just going to quickly swap 9 and 45, 9 and 45. So what did I do here? I just swapped that, right? So in the remove part, right? In the remove part, I'll just write self.swap. What I'm going to be swapping. Remember, swap is going to take two indices here, right? The first index and the last index, or the second index, right? So what will be my first index here? It should be the 0th element, right? Or the smallest element. And the last index should be length of self.heap minus 1. And in which array or the container or the data structure I want to swap it, it's basically the heap itself, right? Self.heap. That's what I'm writing here. And again, I'll just remove the pass thing here. I think we are done with the swapping part, right? Now let's see what we have to do further. Now my next step should be to remove the smallest element. And where is the smallest element? It's basically the end element as of now. So I'll just remove it, right? So I'll just remove it. And up here, I'll just write self.heap.pop. And what does the pop function does here? In Python, basically pop function, if given no numbers, right? If I give a number like 1, so even if I give no number, it's going to pop from the end of the array, which is in this case the heap, right? That's what I'm dealing with. It's going to pop from the end of the array, which in this case we are dealing with heap or just heap, right? It's as simple as that. So now that we are done with that, let's just see further explanations. Now that we have removed that, now you can see that 45 is out of place. Oh, my bad. So 45 is out of place, right? 45 is out of place, and everything is kind of seems like out of place. So how do I fix that? So the best way to fix that is applying the shift down operation on the topmost element or the root element. And where is it located? It's located at 0, right? Let's just get started. So I'll just write self.SiftDown. Now notice that SiftDown is going to be taking few parameters. Let's just see. So current index and the end index and the container, which is heap. So I'll just write the current index. So my current index will be 0 because that's what I mentioned, that we are going to be shifting down from the 0th index, right, the 45. So let's just get started. So SiftDown 0, comma end index will be nothing but length of self.heap -1. And what will be my container? It's going to be heap, right? Okay, my bad. There's a small typo error or typing mistake. Now that we are done with this, I think we are good to go. Also, if you want to display the user that, okay, which element was removed, right? Then one small trick you can do here is just write that value underscore removed was equal to this thing. So value removed was self.heap.pop. It's going to be removing from the end of the heap as mentioned earlier, and it's also going to store in this variable. So it's not like that it's still there in the heap, but it's not there in the heap, but it's stored in this variable. And I hope that makes sense. It's clear. So I can just kind of return from the remove function value removed was, right? So value which was removed. I am not really good at grammar. So value removed was whatever the return value will be. Okay. And basically the return value up here will be value removed was the minimum or was the smallest, I'll just remove the cursor, smallest value in the heap or container or MinHeap tree, whatever you may call it, right? Whatever you may call it in the world. But the main thing here is you have to understand the concept here, how it's working. Not that we are done with this. Let's just implement the SiftDown method, right? I'm really excited for that. And if you already remember from the last video how we approach the SiftDown method, let's just get started. So maybe I'll just remove this here and write it cleanly, 45. So what do we do in SiftDown? It's as simple as this. So I'll just consider the parent node or the current node, as of now it's 45. I'll consider its children 12 and 23. I'll consider the minimum of its children, right? So what is the minimum of 12 and 23? It's 12. And then I'll check that if the minimum of its children is smaller than the current node, I'll swap, right? I'll swap. But as of now, I'm not swapping because I'm writing the code right now. When we come to that part, I'll just swap, right? Okay, let's get started. So where will be my child one at? So my current index, so I am at current index or current index IDX. So where will be my child one? So my child one index will be at basically current index multiplied by 2 plus 1. I hope it's recorded, right? Let's get started. So my child one index or the index of the first child will be current index multiplied by 2 plus 1. And if you were wondering how the heck the formula came in to play or came into the picture, you can kind of watch the previous video, right? And now that I've calculated the index for the first child, I'll check that while, right, I'm not going to be using if because that's going to be looping only once. I'll have to loop it until the end, right? So while child one index or the index of the first child is less than equal to the end index, that's the reason I'm taking the end index here, right? So while this is happening, right, while the condition is being satisfied, right? While the condition is being satisfied, what I'm going to be really doing? Well, I'm going to be computing the child 2 index or the second index or the index of the second child. So how do I do that? So child 2 IDX is going to be basically current index multiplied by 2 plus 2 and not 1. Plus 1 is for the first child and plus 2 is for the second child. As simple as that. Now I'll check one small edge case here. What is the edge case? I'll be checking that if child2 index is greater than end index, right? If it's greater than end index, then maybe then I can do a small trick here. What is the trick? I'll just set child2 index to maybe a string not valid, as simple as that, or maybe n valid. So what is n valid here? Or maybe just write nv, right? So nv stands for not valid, as simple as that, right? You don't have to worry about what nv is when you go through the video later. So that's why I've written small abbreviation. Nv is nothing but not valid, right? Now I'll check that. Again, I have to compute the minimum of child1 index and child2 index, right? So I'll just check that if my child2 index, right, is not equal to nv. So if my child2 index is not equal to n not valid means if my child2 index is valid, right? Then in that case, right, in that case, I'll check that and the element at the child2, right? So heap of child2, wait, so I'll just write child2 index is smaller than the number at the child1 index, right? Child1 index. So this means that I'm checking that whether my basically child1 or maybe child2, right? Okay, where is my cursor? Yeah. So I'm checking here that is my child2 less than 12? Is it, for example, if instead of 12 and 23, if this was 52 and 23, then is 23 less than 52? Yes, it is. So what I'll do, I'll just write that index, so idx to swap, right? So index to swap is going to be child2 index, right? That's what I'm going to be swapping. So I'm going to be swapping 23 instead of 52 with the parent node. Again, I have to check with the parent node, but that's something else. So index to swap will be 23. But as of now, for example, this Control Z, okay, it's not working. Yeah. So as of now, it was 12, right? So in the else part, right? In the else part, else, what if the child2 is not smaller than the child1? What if 23, right? So what if 23 is not smaller than 12? Yes, that's the case here. So my index to swap will be 12. I'll be checking for 12 with the parent. So my index to swap right here, I'm just going to write basically idx to swap is going to be child1 index, right? It's as simple as that. Now that we have the minimum index, again, I'm going to be checking for one small condition, whether the index to swap, right, whether it be child1 or child2 index, is it actually less than the parent node, or which is the current node, as in this case. So I'll just write as simple as this. So if the number at the index to swap, right, the number at the index, whatever the index we are swapping at, is less than the number at my current index, right? If it's less than that, then again, it's as simple as that. So I'll just call my helper function swap. What is the first parameter I will be passing? It's index to swap, and then I'll just pass current index. And what is the container here? It's heap, right? It's as simple as that. No drama and nothing as such new we are learning. And once this is happening, right, my current index will be updated as current index is basically index to swap, right? That's where I'm going to. And again, now I'll compute the child1 index. So my child1 index will be basically current index multiplied by 2 plus 1 at the end. It's going to be, okay, my bad. So plus 1. Do I need to compute child2? Well, I could have, but there is no need, because when this condition satisfies, the child1 index is going to be computed as a new child1 index. And again, when this condition satisfies, this while condition, as I've written, condition is being satisfied. If it satisfies, then child2 index will be computed automatically. And again, there will be checking of edge cases here, right? This is the edge case. So now that we are done with this, I'll just go through the SiftDown method here. So child1 index is current index multiplied by 2 plus 1. I'll just check some formulas. So current index multiplied by 2 plus 2. Yeah, that's perfectly right. Now, notice here that once, if the condition up here does not satisfy, then we are going to be simply breaking. And I'll just explain that in a minute. So I'll just break here. And why do I do that? Let's see. So imagine, right, imagine that instead of 45 here, right, instead of 45, maybe like I had a number like let's just get started, right, so 17, or maybe like I'll just have a number as 16 will do, or no, let's see. Okay, let's just go ahead with 16. So is 16, so I'll just have minimum of 12 and 23. So 12 is 12 smaller than 16? Yes, it is. So I'll just swap, right? So I'll just swap here. So 16 will come up here, 12 will come up here, right? Yeah, this is the best condition here. Now I'll get the minimum of 17 and 31. This is my current node. I'll get the minimum of 17 and 31. Minimum is 17, right? So index to swap is index to swap, or the element at the index to swap is basically 17, right? This is not the index, but the element at the, or the number at the index to swap is 17. Now look at this condition. If the index, if the number at the index to swap in the heap is smaller than the number at the current index, is 17, is the index to swap is smaller than the current node or the current index? No, that's not the case. So that's why I've written else break, because if I swap 16 and 17, this will be out of place. You can see here, right? If I just swap these values, then this is again out of place. So I don't need to do anything. And this is the point where I'll just halt the process or stop the process. So 16 was here and 17 was here. And this kind of satisfies the heap MinHeap property. 12 is smaller than both of its children, 16 is smaller than both of its children, 17 is smaller than both of its children, 23 is smaller than both of its children, 31, 30, 44, you don't need to consider because these are the leaf nodes and have no children at all. Right? It's as simple as that. And this is the reason why I have written else break. If this does not satisfy, if this satisfies, then we are good to go with these functions, or with this helper function, and maybe like the new value of current index and child 1 index, or the index of the first child. Else I'm going to be breaking out, right? It's as simple as that. And do you know what's left? We are left with nothing, right? We are done with the entire coding part. I believe so. Build heap is still there, right? So I'll just try to complete this. Again, when we are doing build heap, as discussed in the last video, I'll be kind of cutting this video short because I have to have some work. But okay, let's just get done with this. I don't think I should be lazy here. So let's just maybe like do one thing. Take a random array, right? Random array out of the blue. So maybe like 100, 12, 3, 45, maybe 5, and let's get it with 1, right? So what are the indices here? 0, 1, 2, 3, 4, and 5. I have to, in the build heap, again, I'm saying this once more, so you have to be watching the previous video in order to understand how we are going to be operating build heap, right? And if you haven't already, you can kind of pause this and watch that into like multiplied by 2 speed, right? You know what I'm saying. So in this build heap, we are going to be processing the elements like this. So we are going to be start from the lastmost parent, and go until the 0 index or the 0th index, right? So let's just see the construction first, right? I'll just draw a small construction here, what this looks like. So it's 100 at the top, 12 and 3 follows along. For 12, we have children 45 and 5. So 45 comes here, 5 comes up here. And for 3, we have only one left child and not right child. That's something you have to take care of, right? Even if you think that, okay, Vaibhav is like talking rubbish, I'll just take this as the right child of 1 and ignore this, right? This is going to be violating the property of complete binary tree. But again, you have to be filling it from the left side. How do I determine that? Check the index of 3. It's 2. So where will be the first child at? It will be at 2 into 2. So 2 into 2 plus 1. That's 4 plus 1, which is 5. So at the 5th index, 1 will come, and this is my first child, right? And I hope that's clear. Now, this is not at all a MinHeap, right? This is not at all a MinHeap. How do I do that? I just make use of the build heap. And how do I get the first parent here, right? How do I get the first parent here? I just simply take the last index, right? This is my position, which is basically 5. So my parent will be at position minus 1 floor division 2, right? Or integer division 2 in case of Python. So this will be 5 minus 1 by 2, This will be 4 by 2, which is 2. So let's just see 2. Okay, 3. So I'm seeing that 3 is the lastmost parent, right? That's what I said here or mentioned here, that start from the lastmost parent and go until the 0th index. So how do I get the lastmost parent? Well, I just have to firstly compute the last index, right? The last index. So my last index or last position is basically length of the array minus 1. And I think I'm recording still now, because once I made a video of 50 minutes and I realized I was not even recording. So last position is length of array minus 1. And how do I get the first last parent, right? So my first, it's not really first, but the first last parent, right? How do I get that? Okay, I think it should be parent. Yeah, perfect. How do I get that? Well, I just do the formula thing, right? So last position, right? So it's going to be last position minus 1 divided by 2. Again, this is something which I explained here in Python is basically integer division or floor division. I'll just copy paste it here. So even while reviewing the code, you don't fall into trouble, as I did when I was first started with the coding part. So let's just see how I'm going to proceed. So as I mentioned in the explanation earlier in this video, that we are going to be performing shift down operation. So shift down operation on each of the parent node from the last to the beginning. So I'll access 3 first. So I'll just access 3 first, then 12, and then 100, and then we are good to go. And the entire thing by the end of the 0th index will be a MinHeap, and that's my guarantee, right? So how do I do a shift down? Again, that's something which I've already implemented and explained. So I'll just try run the code here, right? I'll just try run the code, and before I do that, I'll just try to maybe like write the pseudo code here. So for current index, current id x, right? So current id x in range. So I'll be starting with the first last parent. I'll be going till the 0th index until minus 1. So basically in Python, the third value in range is the step down or step up value, right? In this case, is the step down value, and it will go till the 0th index. This is the reason I'm writing minus 1, right? So it's going to be going till the 0th index. It's as simple as that. Now, for every current index, right, I'm basically accessing the parent one, right? So for every current index, I'll just do shift down, right? Shift down. And again, you don't need to worry. I'll be explaining the entire BuildHeap operation there, right? So self.shift down. What else do I need to give? Maybe let's just refer the arguments here. So it's current index, end index, and heap. Okay. So what will be my current index? Let's just analyze. So basically my current index might be current index itself, right? Current index, and the end index will be basically the length of the array, right? The length of the array. Okay, my bad. I just went down. And in which container I'm trying to do the changes. It's as simple as array, right? Doing nothing. It's as simple as that. Now, at the end of the day, what I want is basically return the modified array here. So I'll just write a return array, right? And while returning array, so this array will be returned up here, right? It will be returned up here, bottom in which I have written. So MinHeap array, and it will be returned up there. I think we should be good to go. So I'll explain the code part, I mean the logic behind it. So maybe we are going to be performing the shift down, right? I'll also change the values in the array or the heap here. So this is my heap represented in the form of an array. I think it's 44 minutes now. I'll just quickly go ahead with it. So consider the minimum of its children nodes. So 1, and there is nothing. So I'll just consider the minimum as 1. Is 1 smaller than 3? Yes, it is. So I'll swap, right? I'll just swap. So I'm swapping 1 and 3. Even in the array, I'll swap 1 and 3. It's as simple as that. So 1 comes up here, 3 comes up here. Again, I'm going to be considering 3, but 3 is actually at the end of it. So it's a leaf node. It has no children, so nothing to compare. And my process for this indices 2 is completed. No need to worry. Just cross this out. We'll be continuing with the next parent, which is 12. So at 12, we'll be looking at its children nodes, 45 and 5. So what is the minimum of 45 and 5? 5 is the minimum, right? And I'll check that if the minimum or the index to swap is actually less than the current index, which is 12, then I'll just swap. So I'll be swapping 5 and 12. So 5 will come up here, 12 will come up here. And again, in the array, I'll be swapping 12 with maybe like 5, right? So 5 will come up here, 12 will come up here. It's as simple as that. Again, I'll be checking 12, but I see that 12 is the leaf node and it has no children, right? It has no children. So that's the point where I end my process. And that's something I have explained in the video quite a few times. So we are done even with the 1th index. Let's get started with the 100th one, right? So I have to sift down 100. Let's see. So consider the children value of 100, 5 and 1. So what is the minimum of 5 and 1? It's 1, right? Is 1 smaller than 100? Yes, it is. So I'll just swap. So I'll just write 1 there and 100 here. What a coincidence. So 1 up here and just write, okay, I'll just clean it up. I'll just write maybe like 1 here and then 100 here, right? It's as simple as that. Again, check for 100, right? Is 100 having any child node left? Yes, it is. Though it is only one child left and not second child, again, we have to consider. So is 3 minimum, which is 3, is smaller than 100? Yes, it is. So I'll just swap here. In fact, I forgot to swap here. So 101 is something we are swapping. So 1 comes up here, 100 comes up here. Again, 103 is something we are going to swap. So 3 will come up here and 100 will come up here. So again, in the main array, I'll just swap 100 and 3. So 100, okay, my bad. So 3 will come up here and 100 will come up here. And I think we are done with the 0th index and the entire thing, array and the entire representation, diagrammatic representation, and the entire heap array is following the properties of MinHeap, which I have discussed in detail in the first video. So let's just check if it's actually following. So is 1 less than both of its children nodes? Yes. Is 5 less than both of its children nodes? Yes. Is 3 less than both of its children nodes? 100? Yes, it is, right? And we are glad to know about it. So maybe like we can just give one small example here. And I think I've taken one example here, 101, 21, 34, 56, 78, 3. I'll just Control S save. And I might be wrong in some part of the code because while I was talking, I might not have paid attention, and that's completely okay. So I'll just try to do Python. What is the name of the file? So it's MinHeap construction.py. Okay. And I think I'm kind of right. So this is something, this is the array which I inputted, right? 101, 21, 34, 56, 78, and 3. This is something which I had as input, right? So this array is going to be converted to heap, and at the end, print array, when I did the print array functionality here, I can see here, I'll just try to, I don't really know the keyboard shortcuts here. Yeah, I think this works. So this is something which I'm getting as heap. Let's just kind of try run this. So 3, 21, 34, right? So just move it here. So it's 3, 21, 34, 56, 78. So, okay, 56, 78, and at the end it's 101. So it's 101. Let's see. So what I'm going to check here is, notice that I'll be having the root element as 3. These are its children. So 21 comes up here, 34 comes up here. I'll just write the indices here as well for you to kind of match what I'm writing. Now, what will be the children of 21? It should be 56 and 78. So 56 comes up here, 78 comes up here, right? What will be the children of 34? It's going to be 101. Is 101 going to be on the right hand side? No, that's a very big no and a very minus point from the interviewer's perspective. So this should be 101 up here. And this entire thing and the entire heap structure is also following the property of MinHeap. How do I know that? Well, I can see that 3 is smaller than both of its children, 21 is smaller than both of its children, 34 is smaller than one of its children, right? Doesn't matter if there is 1 or 2 children here. So I hope the entire explanation kind of makes sense or made sense, and believe me, I'll be posting the codes out. So I mean, I'll be publishing the codes to basically, I don't want this imported. So I'll be publishing the codes to GitHub repository, and then I'll be sharing the links because I think I've made videos on maybe count of inversions and one more video. As of now I can't remember. It's array of products, and this is the third one, right? So okay, these are the files here. So these are the some explanations or the codes which I will be publishing to GitHub, and then I'll be sharing the link. And you don't need to worry about that. Till then, you can kind of understand the concept quite well enough, and then we can kind of maybe like enjoy the content, right? And again, I'm not asking you to basically subscribe to my channel, press that bell icon and all of those things. I mean, you can just kind of come up here, have a good time in your free time, watch the videos and learn from it, right? So my message would be to just simply learn from the videos, right? The main important part of YouTube, to like, if you want to make a good use of YouTube, it's going to be making the most out of it. I mean, there are various free courses out there, but still we procrastinate for resources, right? We kind of search or maybe disturb others, or maybe like basically we ping others, DM others that what are the best resources out there. Well, it's already available on YouTube. I mean, there might be some people who are developing better content and better explanation than me, and it's completely fine. I really respect that, and I would be happy to meet or like read their lectures or watch their videos. But it's the case that, again, you don't even have to subscribe. Just watch the video, practice it, right? Even if you like watch the video and just had the concept in your mind for 1 or 2 days, then it's not going to help. Get a rough copy, practice it, practice, and until you have that in your back and at the back of your mind, right? So I hope this video was helpful, and maybe like we can meet in the next video.